Hello and welcome to Engineering Thoughts, where engineering minds come together to discuss topics of interest to our industry. I'm Vanessa Sealy-Fisher and I'm joined today by industry experts Kevin Nicholas and Neil Webb. Thank you, gentlemen. Today, we're going to be tackling the important topic of root cause analysis of coating failure investigations. Now, whether you're a professional in the field or just curious about materials, we know that you're going to find today's discussion really interesting. Gentlemen, let's get started. If we're talking about coating failure investigations, it's probably a good idea to just remind ourselves what coatings are very briefly. Neil, do you want to kick us off?
Yeah, sure. The point about a coating is that the coating separates the underlying structure from the environment. And in so doing, it prevents the underlying structure from corroding. And we're generally talking about corrosion protection, in this case by means of coatings. And if that coating fails, then the coating can no longer prevent corrosion. We'll end up with corrosion of the underlying substrate, which can cause, at the least, you don't want to land up with a rusty-looking structure, but it can cause actual structural failures, it can cause leakage, it can cause environmental damage, and so on. So we don't want our coatings to fail.
Sure.
And today's discussion, I think, really is to unpack some of the situations that we've experienced. We're going to tell you some more stories about what has happened when coatings fail. And sometimes these coatings fail for rather obscure reasons. And the process of trying to find out why a coating fails is just as important as how it fails and what the subsequent consequences of that failure are.
Kevin, from your experience, we talk about a coating failure. As a woman, the failure of a coating might be chipped nail polish. But in your experience, what are some of the examples that you would notice that the coating has failed? How does it manifest?
Well, the worst case scenario would be where the coating would just disbond and fall off, for want of a better word.
So you find it on the ground?
It just lies on the ground and there we go. There are other failures that would be visible, cracking, blisters. So that's not the only way that it would be falling off, that you could see that the coating has failed.
And I guess sometimes coating failures can actually occur because there was underlying corrosion that bursts through from the outside. And I guess that might become evident during the investigation.
That's possible, yes. Anything is possible, and that's why you go and try and do the investigation to find out what was the cause of the failure.
So let's imagine now you've been called to a project. Where do you start, Neil, with this Sherlock Holmes impersonation that you're going to be doing?
Well, the most important situation to address is what is the overall environment. So what is the coating exposed to, firstly, and what is the process going on within that environment, and what does the coating look like? Is it a general failure over a large area, or is it a specific point in the structure that has failed, or the nature of the failure often tells you whether there was perhaps some external contamination that occurred, that the coating had been sprayed with acid. That's an extreme situation, but not impossible. And sometimes it's extreme, it's absolutely obvious. On one occasion, I was asked to go and investigate it wasn't to investigate the failure was absolutely obvious, but it was to evaluate the extent of the failure, where a sulfuric acid tanker had been busy loading concentrated sulfuric acid, and the hose burst and sprayed concentrated sulfuric acid throughout the cab and everything else. Fortunately, the operator was following safety protocols and was safely ensconced in a remote control cabin. But that tanker was a complete write-off as a result of the attack of the acid. Now, that's an extreme situation. We didn't really need to do a failure investigation. It was perfectly obvious that the cause had been a failed hose.
Now, is it necessary to physically go to the site of the failure investigation? I presume that's first prize.
I think that is first prize. And like Neil was saying, it gives you a very good idea of where to start looking. If it's 100% of the area where the coating lining is busy disbonding and falling off, a good place to start looking is at surface prep. If it's an isolated 5% of the area that it's failing, I wouldn't say that it's a surface prep that's been the problem. You've got to start looking somewhere else. Was it external factors that have damaged the coating or lining? And for that reason, it's always a good place to start at the surface or at the actual site and see for yourself what has happened.
I suppose there are some situations where a virtual investigation has been needed, let me not say during COVID, but there's also the challenge that when I'm describing to you the situation, I go, it's failed, all of it's failed, and I'm very dramatic, and actually it's just a small portion that has failed.
Well, I had a situation a few years ago when a client started getting suspicious about the quality of some coating applications on a new plant extension. And they asked me to go and have a look at this situation. But before I went, I asked them to send me the quality control records.
Right.
And I had a look at these quality control records, and I could almost write the failure investigation sitting in my office, just looking at the quality control records, because they had done the surface preparation, the priming and the overcoating all within a space of 4 hours, according to the records. So there's no ways that that coating could have cured properly. And the importance of these quality control records is not only that they are taken, but that they are accurate, because those records, and I think Kevin has a very strong opinion on the way those records were written. Those records either were not true, or because they were just too good or too repetitive, or if they were in fact correct, then there was no need to go to site, because you could say, well, yeah, you had solvent entrapment, you had a lack of cure, you had inadequate intercoat timing and overcoating, and.
I think what Neil's saying is very true. Often quality control records are filled in an office, and you can see it, blatantly see it when everything is perfect. Often the guys actually rewrite the same thicknesses over and over, which Neil says was a situation on that job. We spoke about it previously, and you can see it immediately. So that's very worrying. As far as virtual investigations, I believe I want to see, feel, touch, pull on the actual coating lining, and I don't think a photo always gives you the exact image of what you want to see with your own eyes. Sometimes the pipe is too small, you can't get inside it, and if possible, get a sample, get them cut out a piece of the pipe and bring it back to you. If you can't, you'll have to make do with a camera investigation. But first prize, I want to actually touch and feel the actual lining that has failed.
And if you've got the situation where you're on site looking at that investigation, at that failure, you're also feeling the environment, the bigger picture that the camera doesn't capture, where it sits relative to other structures, where it sits relative to people doing their jobs, or traffic, or the bursting sulfuric acid tanker, etc.
One thing that I always battle with is that you get sent photographs of a situation. I do a lot of technical photography, and I know that how difficult it is to get a photograph that truly represents what you see.
Yes.
And frequently, the photographs that you sent by somebody taking a photograph of a piece of rusty pipe or a blistered coating or something, and you look at this, and actually you almost want to say, but why didn't you take a photograph of that? Yeah. Because that is the critical point, and you've missed it completely. And the photograph has been taken, the component has been chucked on the rubbish dump, the evidence is lost, and you actually can't do the investigation properly.
You're also not sure what the orientation of the photo is, which side is up, which side is down, and it actually makes a difference.
Yes.
What it is.
Yes.
And you can't always get that information once they've taken the photo and sent it to you. You ask the individual who took the photo, and they don't know.
And the other thing in terms of speaking to people who are involved, whether they were involved in the investigation, whether they were involved in the original application of the system, is that you have vested interests.
Yes.
And the client or the owner of the asset obviously wants to blame somebody else. The applicator wants to blame the coating supplier. The coating supplier wants to blame the applicator and the end user. And it makes getting to the real root cause, as our subject indicates, makes it very difficult to get to the real situation, the truth behind what happened. Kevin, how do you handle that in terms of who do you ask and what do you ask? And I know Vanessa often says, well, I can go on site and I can engage in sort of irrelevant social chit-chat with somebody, and in the process, I just extract all this information that they don't know that they're giving me.
Yeah, well, often what I try to do is get into a workshop. Instead of actually asking the guy who's applying the paint, the spray painter, ask somebody who's maybe 1 or 2 steps away from it and ask him, are the guys busy spraying in winter, 6 o'clock in the morning when it's ice cold? And he's more willing to give you the answer because he doesn't understand the implications of doing that. Where the spray painter is very reluctant to give you the right answer because he knows what is right and what is wrong, or he could possibly know what is right and what is wrong. So take a step back, look around and see who might not know what all the rules and regulations are and what is right and what is wrong, and go and ask that individual, and you might get the truth.
Yeah, I had a situation where we were investigating the application of a fairly complex coating system, and I got talking to the operator of the spray equipment, and we were talking about the benefits of different coatings and so on, and he just dropped the comment that this material that they were spraying with now was so much better than the other stuff that they'd been using because the filters used to block up all the time. So if your filters block up all the time, what's going to happen? The material's going to go off ratio.
There's something wrong.
Yeah.
Shouldn't be.
Yes. I think the awareness in the investigations of finding those little gems that aren't at first obvious, but also give us so much information is critical. The other thing that I think is perhaps underrated is looking at the chemical analysis of the material. When we've got a coating failure, is there a ratio issue if it was a 2-part or multi-part system? What does the specification say? What do the data sheets say? And what does the chemistry tell us is actually going on? And I think there's value in that may not always be asked for correctly if there's insufficient knowledge about how that works, but also in interpreting what you're finding. I don't know if you've got any comments in that regard.
Yes, well, we had a situation once where a multi-part coating was being applied, and the contractor had the application records. They had external inspection. Everything had been done in accordance with data sheets according to the inspection records, but the material had been sourced from different suppliers or different factories with ostensibly the same material. It was product XYZ from this manufacturer, different batch numbers. We discovered that this batch number had come from a factory in one part of the world, this batch had come from a factory in another part of the world, and the stuff that had been supplied from one particular factory had evidenced this failure. And the manufacturer maintained that this was the same product. It's XYZ. When we actually analyzed the materials, which we can do, things like infrared analysis and stuff like that, we found that there was a significant difference in the chemistry of the same product from 2 different original suppliers. Yeah.
On that note, what I want to just bring to everybody's attention, that could only have been brought or picked up with batch numbers, focusing on batch numbers, 2 different batch numbers of material. And you could only get that if people recorded the batch numbers of the 2 different materials. So again, the records must be kept of material. Keep them. It's important. You need it when something goes wrong. Everything is perfect while it's going well. When it goes wrong, it goes horribly wrong, and then everybody starts running around looking for that information.
And we always find ourselves rushing and saying, oh, I'll do the documentation later. And actually, I think your hobby horse of documentation is a valuable one, that we really do need to capture it while we remember, while we have the scribble notes that we've taken down on site, and we actually record it formally.
Definitely. And batch numbers, people often think, well, the batch number was that yesterday, so it must be that today as well.
Yes.
No, it isn't always the same.
Yes.
It can change.
And I've also seen on site where they'll fill in for the week and they'll say it's batch 1, 2, 3, 4, 5 for the grit, and it's batch 2, 3, 4, 6 for the paint, and they're filled in Monday to Friday, and we're only on Wednesday. And we don't know that we're not going to change that.
It's one of the things that we emphasize in courses that we run on quality control, that the inspectorate, and whether that inspectorate is an independent inspectorate or whether it's the in-house quality control department or the client's inspector, it doesn't matter who, that the accurate maintenance of records is absolutely crucial. And your daily report doesn't get filled in on Fridays. It gets filled in on a daily basis. And you need to record batch numbers. You need to record environmental factors. There was a very interesting situation that happened quite some years ago where a product had been applied to a pipeline. The pipeline was intended for service above ground. It was being slung underneath a bridge. And a certain section of the pipeline, the coating failed. The coating was a moisture-cured urethane. When they went back to the construction or the manufacturing records, they found that the environmental conditions that pertained when those particular pipes were coated were such that there was inadequate moisture in the air to allow for full cure of the coating.
It seems such a little thing, doesn't it?
Yeah.
It's a lovely, dry, sunny day. Oops, not good for this coating.
Yeah.
Well, there aren't many products that would fall into that category. So the majority of people just think, well, it's got to be dry,
Yes.
low humidity, to put paint on. And they forget about those moisture-cured urethanes, the inorganic zincs that want moisture to cure.
Yes.
And they don't think about it and just carry on. And how many failures have there been with inorganic zincs in the Highveld in the winter months? They just don't have enough moisture to cure. Yes. And I think people also don't always appreciate the importance of reading a data sheet before you get involved with the product. If you're the applicator, the inspector, I don't care who you are. If you're busy with a product, read the data sheet.
Yeah, for sure.
Yes.
It's not a case of when all else fails, read the instructions.
No, read it before.
You read the instructions so that everything else doesn't fail.
Doesn't fail.
Yes.
Yeah.
And I think it's also really important in a failure investigation that having got all these little bits of information, so you've now looked at what conditions the structure that's failed is in today, and you've gone back to historical records, and we've looked at the chemistry, and we've looked at the morphology now. We need to tie those all together so that somebody else can learn from this mistake. And that also can be a challenge to communicate that adequately.
I don't know how a person gets that right. That is a challenge, yes.
Because people don't want to admit that they had a problem. I think we are fortunate here in South Africa that we don't have such a litigious society. But there are areas of the world where the only people that get rich out of failure investigations are the lawyers. And everybody else loses. And the whole point of failure investigations is to prevent future failures. I mean, the aircraft industry is a wonderful example of the benefit of proper failure investigation. When a plane falls out of the sky, unfortunately, more often than not, a lot of people die. But the analysis of that failure prevents that failure from happening again.
Yes.
There have been a number of them recently. We won't unpack those. It's not the purpose of this discussion. But that is a really, really good example of the beneficial results of failure investigation. Rules and regulations get updated. Products get actually removed from service because they're not considered safe until the cause of the failure has been addressed.
But that methodology can be used anywhere.
Absolutely.
Everywhere.
It should be.
And it should be. Yeah.
Yes.
Yes. In the safety sector, they have the concept of the near miss. A failure investigation is a result of not a near miss, it's a real miss. But if we did take that information and applied it, how much better off we would all be? That's fairly philosophical, I know.
No, but like Neil said, people don't want to admit to failure.
Yes. How do we change that?
Good luck.
Well, I think that should be what we strive for with these root cause analyses, with these failure investigations, is that we can share this information in the industry so that we can learn from past mistakes and hopefully reduce the number of failures going forward. I think we've seen an increasing number of failures in the construction sector, and it's causing questions to be asked in that sector. Often the coating failure investigations, many of them don't result in catastrophic loss of human life, building collapse, that sort of thing. But I think they're as valuable to be taken seriously as the really big stuff.
Yeah, I think one of the aspects that goes back to a comment that Kevin made earlier about record keeping is that I can't say it's a universally recognized challenge, but it has certainly been identified that in coating applications or the use of coatings in the corrosion protection industry, the majority of failures are related to the quality of surface preparation. And one of the problems that we have with regard to coatings and quality is that once you've applied a coating over the surface, you don't know what's underneath it.
Until it fails.
Until it fails, yes.
Yes.
And the problem with record keeping is, and I've seen it on 2 occasions, one with a recent failure investigation, where the record keeping, the guys, I'd say due to a lack of training, are keeping records, and when it's temperatures being kept, where the actual ambient temperature must be recorded on a document, they are busy keeping the wet bulb temperature. It's being recorded and nobody is noticing it. Day in, day out, week in, week out, they're keeping it and nobody notices it. Off you go.
I think you're right. That's lack of training, lack of understanding of what they're doing. And perhaps we need to upskill the people who are making those records to understand what they are capturing.
And why?
And why. Maybe we can make a little inroad into helping to understand the why so that other people will understand the benefit of doing their job properly. Well, thank you very much, gentlemen. I think this has been an enlightening discussion, so I appreciate and value your time. If you have any questions or topics you'd like us to address in future episodes, drop a comment below. We look forward to sharing more engineering thoughts with you. And until then, stay curious.